Good afternoon, everyone. Dear authors and invited guests, I welcome you all to the technical session 6G. Myself, Siddesh Mughal, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 16th and 17th, 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answer. On 9 minutes, I will raise a gentle reminder. If you have any queries or update, then you can write it to me in the chat box. There is another request to all the participants that you all stay connected with us till the closing remarks. Just before we start, I would like to introduce you to the chair of the session, Dr. Dushyant Singh B. Rathod. Dr. Dushyant Singh B. Rathod is a professor and head of department at Gandhinagar Institute of Technology, Ahmedabad, India. He brings over 11 years of technical teaching experience along with 4.2 years of industry experience. His research interests span artificial intelligence, machine learning, deep learning, data science, and Internet of Things. Sir, do we have a session chair? Yeah, I think there's some technical problem by his side. Okay, let's move further. So the first presentation is presented by Shiva Karthik. He is presenting Adapting Whisper for low resource and code mixed Indian languages, a multilingual approach for speech analysis.
Hello, sir. I'm the first author of this paper, actually. My name is Akshay,
Okay,
and
okay.
Shiva Karthika, sir, is in actually CDAC Delhi for another presentation.
Mm-hmm.
So, as the first author, I would like to start the presentation.
Yeah, sure. You can present on behalf of him.
First of all, good afternoon, sir. Um, we have a paper titled Adapting Whisper for Low Research and Code Mixed Indian Languages, a multilingual approach to the speech analysis. And in this work, we address the problem of the multilingual automatic speech recognition for Indian languages, which remains challenging due to the code mixing, accent diversity, and limited label data. So we proposes an end-to-end speech analysis pipeline centered around this whisper model, which is augmented with speaker diarization using SpeechBrain and Pioneer Audio. Our system is designed to work on real world and noisy audio and which supports speaker-aware transcription across multiple Indian languages. Through extensive experimentation, we demonstrate the consistent improvement over baseline models and particularly in low research scenarios. So, uh, yeah. So here I would like to introduce this models, problems, and its solutions. So India presents one of the most complex speech processing environments in the world, where there is a linguistically diverse uh, country with 22 plus official languages and hundreds of dialects. So the major challenge here is that is a phonetic and script diversity across 22 plus languages, and there are also multiple dialects which have various accents and more uh, noisy as well as frequent English code mix data, which we use while WhatsApp chatting or social media and like that. So in real world settings, speech is rarely clean, and speakers frequently mix native languages with English, and accents vary widely. Also, background noise is common. So, most existing automatic speech recognition systems are trained on the clean or language specific data, which fails to generalize under the conditions. This motivates us the need for a robust and multilingual speaker aware ASR system, which performs well beyond the control datasets. So I would like to say that previous to this model, Whisper, which is a model by OpenAI Whisper, there were earlier ASR systems which involved HHM, GMM architecture, that is hidden mixed models and Gaussian Markov models architectures to deep learning and transformer-based models. So while multilingual ASR has improved significantly, most prior work still relies on language-specific fine-tuning or independent pipelines for transcription, diarization, and translation. So these approaches struggle with code mix speech, unseen accents, and low resource languages. So our work differs by leveraging a single, strongly pre-trained multilingual model, integrating speaker awareness in its unified pipeline. So there were CALD as well as wave-to-wake models, as well as a lot of other models over there. But Whisper is a model which has been trained extensively on 680,000 hours of supervised data. So it gives the leverage uh, in cases of code mixing or overlaps, like a lot of things, which previous models which were self-supervised or unsupervised, which were not able to do on multilingual approaches. So why Whisper? So that's what I was saying. Ki Whisper, uh, it is good for uh, code mix languages, which means that if our language contains two or more languages which are mixed with English or Hindi or Marathi or any kind of those languages. So Whisper outperforms over there. It is a state-of-the-art model. So this large-scale pre-training gives it a strong robustness to noise, accents, and spontaneous speech. So uh, plus it doesn't need a lot of annotations, which is used in like previously wave-to-wave models and all. Another thing is I would like to move over the overall system workflow. So let me briefly walk through the overall workflow. So the system takes raw multilingual audio as an input. First, the language identification and voice activity detection are performed. And next, the speaker diarization segments the audio into speaker homogeneous regions. Whisper then generates the transcriptions for each segment, which are aligned back with speaker identities. And the final output is a speaker-aware, time-aligned transcription with the optional translation when required. So these are all time-stamped, searchable, speakerable. So the token IDs are uh, aligned by using the tokenizer, and the audio features are extracted using Whisper feature extractor, which pre-processes the raw audio inputs, and then model does the sequence-to-sequence mapping. And as I said, Kit, that tokenizer post-processes the model outputs to the text format. It aligns them. And what Whisper does inside is it takes the raw input audio, uh, and it divides it into the chunks of 30 seconds. So any audio which is less than 30 seconds is padded with a silence or zero. And more than that, if it is larger than 30 seconds, then it is truncated into the blocks of 30 seconds. So I would like to continue with the dataset preparation, that how we did it. So languages covered are most of the multiple Indian languages that are mentioned in the table over here. That is Hindi, Bengali, Gujarati, Malayalam, Tamil, Telugu, Kannada, Marathi, and Punjabi. And what Whisper expects is the 16 kilohertz of frequency, which generally most of the audio data doesn't have. So most of the audio data is like 36 K kilohertz or like that, but we have to resample it using the sound file module or FFmpeg. So we do what we do is we do text normalization, silent streaming while pre-processing of all the data which has like noisy audio or like which are spontaneous in speech or like mixed language utterances. So for this, we have used three data sources, which is OpenSLR dataset, Mozilla Common Voice dataset, which has the like labeled audio mapping, and we also have attached with this like proprietary conversational data from our organization using crawling. So for this, we have used the datasets module. And the proposed approach here contains like 10 languages, as I said. So the core idea of our approach is to treat Whisper as the ASR backbone while enhancing it with speaker intelligence. Instead of modifying Whisper internally, we use a modular pipeline where diarization and ASR operate independently. Their outputs are merged using timestamp alignment. This design allows flexibility, easier debugging, and ability to swap the components without retraining the entire system. So what we do is we have fine-tuned this model. As we have said here, like we have curated 2000 hours of data, and we had four NVIDIA H100 uh, GPUs from Param supercomputer for training. So it handles the data of variable audio lengths, and like incorporate all kind of clean, noisy, and code mix data. And the metrics we have used are a word error rate, direction error rate, and like LIA on held out real world test. So I would like to move next to next slide. So overall, this workflow that I have explained you is like uh, I have already told you that we take an input, then we divide it into the chunks of 30 as the Whisper expects it. We resample it to the 16 kilohertz and all. Then a LID is done, language identification, and then we completes the next process as I have mentioned. So
Akshay, sorry to interrupt, but your 9 minutes are over. Kindly wrap up.
okay. So I will wrap up in like 2 minutes. So as we know Whisper's architecture, what we have done extra is like we have integrated it with SpeechBrain. So SpeechBrain is a Python library, which what it does it specifies the specifically extracts the speaker embeddings using Escapa TDNN models. So it provides voice activity detection and lightweight speaker representation suitable for near real-time usage. So these embeddings help in clustering and identifying speakers within an audio stream. So the next thing is like the another Python library or a model which is Pioneer Audio. So what Pioneer Audio does is for high accuracy diarization, like it excels at handling overlapping speech and complex conversational patterns. So it is particularly effective in offline processing where latency is critical. And in our system, Pioneer complements SpeechBrain by improving the diarization quality in challenging audio conditions. So the results we found that previous wave-to-wake and CALD ASR models and Libre speech ASR data's whisper output, our system relatively improves the word error rate by 4 to 10% relatively, in major cases by 8%. Um, and the error analysis, that common type of errors we still are getting, but it is improved from the previous situation. So what is despite improvements, some errors do exist, but we also have a future scope for this. So I would like to conclude, and we as we presented a robust multilingual and speaker-aware ASR system tailored for Indian languages by leveraging Whisper's strong pre-training and integrating state-of-the-art diarization tools, we achieve improvements in real-world conditions. And future work also includes exploring lightweight and Whisper variants, expanding the dialect coverage, and enabling real-time streaming. Uh, Thank you, and I look forward to your questions.
Akshay, I
Hi.
think our session chair is not with us. He has some technical issue.
Okay.
So we'll move further.
Okay.
Yeah, thank you.
Should I stop sharing screen?
Yeah, yeah.
Okay.
Yeah, you can stop, Yash.
Uh, do you have any questions?
No, no, you can stop.
Thank you.
Moving next. So next we have Yash Shinde. He is presenting application of machine learning and empirical mode decomposition EMD in prediction of depth of smooth zone in AWJ cutting by vibrating signals. Yash, are you there?
Yes, sir.
Yeah, you can start your presentation.
Okay. Okay. First of all, great good afternoon to the respective sir. Myself, Yash Shinde. and today I am here to present my research paper in front of you, which our topic and title is the application of machine learning and imperial mode decomposition in a prediction of depth of smooth zone in abrasive water jet cutting by a vibration signal. So I will start with the introduction. We all know that abrasive water jet machine are widely used in the industries to cut the hard and complex parts, mostly in the aerospace and chemical industries to cut a material. Uh, for this study, we select one material which has tolerance, which cannot cut by normal composition machines because it's create a lot of heats and a low thermal conductivity. Because of that purpose, we use the abrasive water jet machine to cut this material. So now I will tell a problem statement. While we are performing the operation over the hash dollar, we see that there will be the depth of smoothing of the workpiece was reducing. Means in an abrasive water jet, when we cut any material, we see that there are the four stages of the cutting material. That is the first is the initial zone, smooth zone, transitional zone, and rough zone. And there is a last is a depth of flow, which tells us the how is the quality and the finish accuracy of the workpiece, which getting poor in our condition. So extra was our material which we cut in this cuts and do experiment. Now I will tell the overall methodology what we do. Like our research is over to research objectives is over to reduce the defects which we get in the finished product which cut under the abrasive water jet machine. So basically, first input parameters where we take experimental data which we perform the 200 experiment over a hash under the abrasive water jet machine uh, by the help of the accelerator which is mounted to near to the cutting object near to the hash which gives the vibration signals to us. These vibration signals we feature out means I will share you which we decompose by the EMD imperial mode decomposition, which gives us some features like RMS, mains, peak. These all the features. Basically, we use the three main features. That is a time domain, frequency generation, and time frequency domain. So in our time domain, it's help us to give how the vibration is strong and tell that the cutting is stable or unstable. That data it's give to us, and then the frequency generation it's give us that how the machine noise will be affect our cutting material or the abrasive impact, and time frequency domain help us to detail it helps into detail prediction to improve the accuracy. Basically our research is over to monitoring of depth of smooth zone and predicting of depth of smooth zone. So after getting the features, we input the features as the input for us. These features we input into the model. There we use a three model. First is a deep neural network, random forest, and decision tree, where the deep neural network is a work like a brain. It's give excellent outputs, but it's required a large amount of data sets. Where the random forest is a combination of decision tree. It's give also good result, but a decision tree is a work like a flow chart. It's not give a required output to us basically. Now this is our materials and specification where we use the materials, and during the operation which performing our hairstyle change the four parameters: pressure, abrasive flow rate, ab- uh, pressure, abrasive flow rate, uh, stand-off distance, and last is what is the pressure, stand-off distance, abrasive flow rate, and the traverse rate. These four parameters will change for every each and every operation to collect the data, and this data we feature out. After the data we collect through a accelerometer in a signal, raw signal, which we decompose here as there is a one raw signal which decompose into the six features. The each feature give us some output input to us. Like one number IBF1 should give us information about the machine noise which occurring during the operation, or IBF2 example, it's give the what will be effect of abrasive while the cutting. This the EMD help us to feature out. After the feature out the decomposition, we will get some input, which input we use into the model. So this is the features where the 15 total features we use: main, variance, root mean square. These all the features we use to remove the input data from a raw data. And this is the important point of your project. This is a model where the first is the deep neural network, which show at this point at the point 7, we show that our training data and testing data has the same value. Means it is a good fitting. It's not going to the underfitting or overfitting. Is a good fitting. As we compare the three data properly, and we see that at the random forest, at a random forest, we are getting the good fitting at a 0.7, 0.16, 0.25 more. We getting a more good fitting as compared to the deep neural network here. So why from all this data we remove
Hello.
the main absolute error.
Hello,
Yes, sir.
Yash. Can you show me a proposed architecture, please?
Yes, yes. This is our proposal. Okay.
Fine. Deep neural network, random forest, and decision tree. So which one is better?
So for our research, it is a random forest gives us best result.
Okay. So what is the novelty in your research?
So our novelty in your research is that we have it will give us the predicted value before the operation. Means it's reduce the defects.
What is overfitting?
Overfitting means like when the both overfitting occurs when the our testing value is good and our training value is poor. That the line where the one line which passes between that it's coincide means it's come exactly over that.
Okay. Why don't you try like some ensemble technique? Hello.
Yes, sir.
Why don't you have try any ensemble technique? You have just use the normal random forest and decision tree methods, but you should try some ensemble technique also. So we'll get a better result.
Yes, sir. But we only use these three.
That's why I'm asking you.
Yeah. We don't go for that because we are only going to predict the depth of smooth zone. Our work is over prediction and monitoring.
So what about the accuracy?
Accuracy, the main absolute error we get that is a 0.8% main absolute error when we perform the when we perform this data in model, we get a main absolute error in a random forest 0.8 as compared to good than a depth neural network. So
Your method, I think your method should overcome the issues of your existing architecture. Does it? Likewise, overfitting problem, underfitting problem, oversampling problem, data balanced problem. But you have not mentioned in your proposed architecture. You should mention everything in your proposed architecture
yes.
so we can have the idea. Fine. Okay.
Okay, sir.
Fine.
Yes. And my conclusion is that if we use our study, like it's help us to predict the data before the operation, and it's also helps to monitor the depth of fusion, which improves the reduce the defects and improve the depth of smooth zone quality. This is our conclusion. Sir, have any question?
Okay. Nice. Fine. I'm done.
Thank you, sir.
Thank you, sir. Moving further, next we have Nitesh R. Nisargi. He's presenting automated phenomenon detecting using CNN. pneumonia, automated pneumonia detection using CNN. Sir, are you there?
Hello, sir. Good afternoon, everyone. I'm going to share the screen now.
Yes, sir, you can start.
Yes. My project is an automated pneumonia detection using CNN. And these are the contents of the project. Introduction of the project is pneumonia is a severe respiratory infection and one of the leading global cause of death, especially among children, elderly, and immunocompromised patients. According to World Health Organization, pneumonia causes about 2.5 million deaths every year, affects a leading cause of mortality worldwide. The disease can arise as a primary infection caused by the bacteria, virus, fungus, or as a secondary complication from viral illnesses such as influenza and COVID-19. And chest X-ray imaging is the most commonly used diagnostic tool but requires the expert interpretation. And AI and deep learning techniques can automate the pneumonia detection from X-rays. And problem statement is that the pneumonia is a major global health threat and its diagnosis relies on expert interpretation of chest X-rays, which is often unavailable in remote areas, and manual techniques is also time consuming. Hence, there is a need for an automated, accurate, and accessible system to detect the pneumonia efficiently from chest X-ray images. And objectives of this project is to develop an automated algorithm for pneumonia detection using CNN and to pre-process and analyze chest X-ray images for accurate feature extraction classification, and to achieve high accuracy, reliability in distinguishing normal and pneumonia-infected lungs, and to provide a cost-effective and user-friendly diagnostic tool for healthcare professionals and rural clinics. And the software requirements of these projects are the Python with the TensorFlow, NumPy, and OpenCV, and Matplotlib for model development and image processing, and Flask for a web interface, and VS Code for development using HTML, CSS, Bootstrap, and JavaScript for frontend. And the methodology of this project is shown in the block diagram, which I am going to explain one by one. And the data set used in this project are from the Kaggle. And these are the benchmark data set for the automated pneumonia detection. And the image type is posterior anterior chest X-rays, and classes of the images are normal versus pneumonia. And chest X-ray characteristics are in normal X-ray, lungs appear dark, air-filled, and clear boundaries, visible heart and bones. And pneumonia X-rays includes a fluid pus in alveoli and localized or widespread. Data set is composed of categories of pneumonia and normal. A total of 5,856 chest images were used, consisting of 4,273 pneumonia and 1,583 normal images. And data set is split into training, validation, and testing in the ratio of 60:20:20. And in data pre-processing, hence there is a need, hence there is a noise or irrelevant background information in the image because of the brightness resolution, uh, because of the lighting conditions. The resize normalization and data augmentation are done. In resize, all the images are resized to a fixed resolution of 24 cross 225 pixels, and normalize is used to stabilize the training process. In this, the pixel values are scaled to range between 1 and 2 by dividing each pixel by 255. And in data augmentation is used to increase the size and diversity of the training dataset by applying transformations like rotation, flipping, brightness, etc. And rotation to plus or minus 20 degree, and like a brightness range up to 10%. CNN architecture. In CNN architecture, we have input layer, convolution layer, ReLU layer, pooling layer, flattening layer, and fully connected layer, and the output layer, which I'm going to explain individually. In uh, convolution layer are a core component of the CNN model, and these layers apply a set of filters to input image to extract the patterns. And each filter slides over an image and produce a feature map. The dot product is obtained between the filter and the input. In ReLU activation, after convolution operation, the rectified linear unit activation function is applied. ReLU introduces nonlinearity into the model by converting all negative pixel values to zero and while keeping the positive values unchanged. In this, for any input values of x, if x is greater than 0, then f of x is equal to uh, output will be x. If x is less than or equal to 0, then the output f of x will be 0. And then the pooling layer. And pooling layer is used to reduce the spatial dimension of the feature map and retaining the important information, and it also prevents the overfitting. In this, we have used max pooling. The max pooling selects a maximum value from a window of a feature map, and by doing this, the model focus on an important feature. And in a flattening layer, the multi-dimensional feature maps are flattened into one-dimensional vector, and this layer act as a bridge between the feature extraction layer and the classification layer. And the fully connected layer, this layer interprets the high-level features extracted by the convolution part of the model. And in this, each neuron in this layer is connected to every neuron in the previous layer, allowing the network to combine the features. And the output layer provides the classification result. And model validation performance. Once the model is trained and validated, the performance is calculating using the following metrics such as accuracy, precision, recall, and the equivalence way. And these are the epochs what we have got. Here is accuracy versus epoch graph. In this graph, the graph shows how the training and value accuracy change over multiple epochs. Both the accuracies gradually increase in the early epochs, indicating effective learning by CNN model. Training accuracy continues to improve eventually and stabilizes at 94.07%. The model demonstrates the strong learning capability and high precision on training data set. And we have a losses epoch curve. The graph illustrates how training and validation loss changes over multiple epochs, and the training loss decreases steadily as the epochs progress, showing effective model learning. A continuous drop in loss indicates reduced prediction errors during training. By the final epoch, the training loss reaches approximately to 0.15, demonstrating good conversions. And in the front-end design, first we create the and activate the virtual environment, and then the Flask is installed with the in the virtual environment. Flask uses the app roots decorator to determine how application responds
Okay,
to.
sir. Okay, fine, fine. Can you show me your architecture? Proposed
Yes,
architecture.
yes.
Okay. So what kind of data reprocessing technique that you have used?
So here I use basic CNN, sir.
No, no. I'm not asking about the CNN. I'm asking about the which data processing technique that you have used.
I use OpenCV, sir.
No, no, it's not like that. Uh, data reprocessing CNN. Then you are just classifying it whether it is a normal or
Yes, sir.
yeah.
Yes, sir.
Okay. So why don't you go for the multi-class classification?
Yes, sir. We can do that, sir, but we require a GPU, higher GPU.
No, no, you can do with the available data set also.
Yes, sir. Yes, sir.
Okay, likewise, whether the patient having the COVID or not,
Yes, sir. Yes, sir.
is or she is a normal or not, or I think like he or she is having the viral pneumonia or not.
Okay, sir.
Fine, and put some novelty or your contribution in your methodology.
Okay, sir.
It is a simple diagram, fine,
Sure,
where
sir.
you
Okay.
are giving the just input and data processing. It will be done and just be applying only CNN.
Okay, sir.
Why not? Why don't you go for the Inception V3 model,
Yes, sir.
sequential model,
Okay, sir. I will do that.
YOLO?
Okay, sir. I will work on that, sir.
Okay, conclude in 1 minute.
Okay, sir. And the flowchart shows that the raw image is supplied by the user in the format JPG, JPG or a medical data, and then the pre-processing. In this, he standardized and enhanced image, so the CNN receives a consistent input uh, and apply operations like resize, normalize, and augmentation. And then the in CNN the process the pre-process image and gives the output probability indicating pneumonia or non-pneumonia. And the model contained layers such as convolutional, ReLU, pooling, flatten, and dense, and the output layer. And in the decision, compares model output probability with the threshold. If the probability greater than threshold, it indicates a pneumonia positive. If the probability,
Sir, sorry to interrupt, but your
yes,
9 minutes are over.
okay, okay. If the probability is less than the threshold, it results the output is non-pneumonia. Then the system returns to the user. Final class label will
Okay,
be
okay, sir. Fine, fine.
okay.
Please, yes.
Okay.
Thank you, sir.
Thank you, sir.
Writing events. These are. Next, we have Saurabh Jain. He's presenting blockchain census evolution, transitioning from proof of work to lightweight and energy efficient protocols. Sir, are you there? I think we don't have Saurabh. Let's move further. Next, we have Lokesh Buddha SN. He's presenting context-aware Sanskrit QA with hybrid retrieval and bidirectional transliteration. Lokesh, do we
Yes,
have
I'm here.
Lokesh?
Yeah. Can
Yeah,
you hear me?
yeah, sir.
Yeah. Good afternoon. My name is Lokesh Buddha, and I'll be presenting my research. I'll just share my screen now. Second, visible. I'll start now. So, our paper title is Context-Aware Sanskrit Question Answering with Hybrid Retrieval and Bidirectional Transliteration. Authors are myself and my team, along with our guide and our mentor from outside. So, yeah, the problem statement. No, nowadays, everyone uses LLMs for even basic tasks like asking any kind of questions. If I want to go out there, we'll ask, find me best places in Chennai or any other place. So nowadays, LLMs are used on from daily tasks to even complex problems. The thing that most people don't realize is that these answers can be hallucinated and can have false information. To rectify this is what they developed was called a RAG, retrieval augmented generation. Essentially, the idea is to provide context to these models so that they are able to retrieve factually correct information. What we are specifically focusing on is in the domain of Sanskrit, specifically Sanskrit epics, and inside that Mahabharata. So, yeah, nowadays the most large language models are trained on a large amount of data, but if we ask them a specific, like domain specific question, they sometimes fail in answering it factually correct. So they often struggle to grasp the metaphoric meaning and philosophical depth of Sanskrit literature like Mahabharata. Like I mentioned, the gap is that sometimes these tend to hallucinate and sometimes they're not even able to understand the philosophically rich text. So, yeah. Related works, these are some of the papers that we refer to where there were limitations as many people have already tried more advanced techniques of RAG, instead of just relying on the basic one, which is just using vector search. There are multiple techniques which were tested, but none of them really had an approach of combining a few of them to see if we can get a better result. So our main contribution is on this field, where we're trying to use a unified hybrid RAG system that integrates structured knowledge with dynamic retrieval to solve these specific gaps. So these are our objectives. First is the hybrid retrieval system. So most of these systems, they either end up having vector search or they'll have a keyword search system. Both are decent when it comes to answering some questions, but they often miss out on either the philosophical answers or they'll miss out on capturing the whole context. So that is why we decided to go for a hybrid system. And yeah, goal two is dynamic strategy selection, is to build a classification model that analyzes these queries and automatically selects the type of question they are so that we can use the specific hybrid strategy for the type of question. So there is not just like one question can have a simple answer of one word, while others require an answer that is a whole paragraph explaining the key details of what is there. So we want to make sure that it's able to map these kinds of questions and give an appropriate answer. So hallucination mitigation is goal three. Like I've stated before, these LLMs often can hallucinate when it comes to very specific domain questions. So our goal is to mitigate this hallucination by providing it more context. And finally, accessibility. This our research allows people who don't know Sanskrit like enough, like they don't know the Devanagari script, and they can use this to give a prompt in English or even in Romanized Sanskrit, and it will be able to transliterate it into Devanagari or vice versa, and use that information to get the context and answer the question. So, key innovation is the hybrid retrieval system, like I mentioned, and this is our system architecture. I'm sorry, the text is not so clear, but I'll just explain each part of it. First, we have the user input, which can either be in English or Romanized Sanskrit, and that is put through its processing, where we are doing the normal like stop word removal. We're using Indic NLP's libraries for handling Romanized Sanskrit. And then once we do all of these pre-processing techniques, we'll be sending that to a classification model. The classification model is a MLP based model because we decided that we don't need a very complex model to classify these questions into our types. And from that information, we are sending it to our Sanskrit focus embedding model. And this is what will actually create the vector that will be used to query the database. The database we're using Supabase, which has a vector search support through PG Vector. So once we get the data that we require, we use these hybrid techniques to re-rank them or break down the question. I'll go more into detail about what techniques we're specifically using in the next few slides. Once we have those responses and the data, we send that to a Gemini model. We chose this model because we found it's the best one when it comes to handling multiple languages. So we use this model, and that model is the final part of our pipeline where it takes this data, doesn't involve outside knowledge. We are told it to strictly focus on the context that we are providing it. And based on that, it needs to create a response and send it to the user. This is our overall pipeline. So yeah, like I mentioned, the query classifier is MLP based classification model. Then our embedding model, one we went with was a Hugging Face transformer model, specifically the all mini LM model. And we chose this mainly because it's able to preserve semantic details and sentence structure relatively well while performing fast. Because of our dataset selection of being Mahabharata, there was a lot of text to process in a relatively short amount of time. So we found that this offered the best trade-off. And the database we use, like I mentioned before, is a Supabase.
Sorry to interrupt you, sir, but your 9 minutes are over.
Yeah, okay. I'll speed it up. So yeah, these are the limitations I've mentioned before, the keyword search and vector search. And the solutions we're providing are these four methods. Strategy one is enhanced recall, which is a hybrid weighted method. Basically, this will be used for questions where you need a short answer, like asking what is Bhishma's vow. That will be like one sentence answer. So here a strategy like this will be used. Decomposition is used for something where you have a large complex question. It will break it down and get context for each of those questions and compile them to use it for the overall response. Strategy three is sentence window retrieval. Essentially, we use this for summarization. It retrieves specific relevant sentences but feeds the surrounding sentences to the LLM to preserve the narrative continuity. And finally, we have RAG fusion, which will be used for multi-choice or ambiguous questions. So what this does is it retrieves all relevant documents from all variants and rewrites them to ensure diverse coverage. This I've already mentioned, why we use the input processing and how it's actually done in our pipeline. The data set that we use is Mahabharata. Why? Because of its enormous size and its linguistic variability and conceptual depth. The data structure, it's not really relevant for everyone. And the tech stack that we use is Python, PyTorch, TensorFlow, transformer libraries, and transliteration libraries, specifically IndicTrans. So yeah, data pre-processing I've mentioned already. And one key point of this is we didn't just take the data and do normal pre-processing like stop code removal in this. We actually sent that data after the initial pre-processing to Gemini to produce summaries and the keywords and entities from that response. This way, we're able to ensure that we're getting a good retrieval for any keyword or any small questions that is asked. Vectorization step, which I've already explained, this is what is mainly used by our database. It's meant for easy retrieval. Then for evaluation loop, we use the Gemini Pro model for its thinking capabilities. And what we do is we tell it to rate it on its faithfulness, its correctness, and how much of it like does the context provide. So yeah, these are the results of the paper. First, we did an abolition study to understand the baseline for what is there, and we found that for these types of questions, what do you call it? The hybrid weighted method worked well, or the hybrid reciprocal rank fusion method worked best. For different type of questions, we found these, and the overall peak performance is displayed in this table. So for multi-choice, we found that rack fusion worked
Okay.
best.
Lokesh,
Yeah.
what is the research contribution from your side in your paper?
So our contribution is that we found that there are no studies where they've combined one or two advanced techniques to see if something a better result can be achieved or not. So what we did is that precisely, sir.
Fine. Okay. What is the real-time application of your research?
So a real-time application would be if, let's say that someone who doesn't know Sanskrit like fully, they know a little bit, they know some Romanized text. They can use our model to try to get a factually and what do you call it, metaphorically correct answer. Like it doesn't take the wrong idea of the whole Sanskrit text. I'm not sure how to word it correctly, sir, but the idea is to give it a factually correct answer while it also being metaphorically right. Because these translations, what happens is sometimes they lose the meaning or they'll get twisted. Our goal is to ensure that that doesn't happen with this model.
Okay, fine.
Yes,
Okay,
sir.
fine. Next, please.
Okay. Yeah, I'll stop sharing. Thank you, sir.
Thank you, sir. Next, we have Aditya PG. He's presenting Meta Campus, an AI-powered virtual reality system for interactive campus tours and learning environments. Aditya, sir, are you there?
Yeah, sir, I'm there. Let me share this.
Yes, sir. Yeah, it's visible.
Okay. So, good evening, everyone present here. So, I am PG Aditya. Today, I'll be presenting our research paper titled as Meta Campus, an AI-powered virtual reality system for interactive campus tours and learning environment. Here, our work explores how virtual reality combines with the conversational AI intelligence, which can transform the way, for students, parents, institutions can experience the campus remotely. So, moving on, the abstract is like told traditionally, physical campus visits play a critical role in student decision making. But however, such visits are often limited by distance or cost or accessibility. So many factors are involved. So for like alternative, many institutions provide like online tools, campus tools, but most are like pre-recorded or non-interactive. So for this, the solution which we provide is Meta Campus bridges the gap between these. So to address these challenges, we are integrating virtual reality with an AI-powered narrative guide, so which enable users to explore the campuses both immersive, interactive, and informative. So, like told, campus infrastructure, academic facilities, environment, all influences the student's choice of an institution. So, however, like every student or parents couldn't visit physically. So, for that, virtual tours will be a solution, but not only relying on like a 360-degree videos or like a web walkthrough or pre-recorded video. So for that, like told, we are proposing Meta Campus, which is an fully immersive AI-driven virtual VR campus experiences. So the problem statement is the core problem which the we addresses in the research is the absence of an intelligent, interactive digital campus tool. So like there is no real-time personalized responses. Like if you have a doubt, like where is the campus, like canteen or restroom or labs, there is no real time for the response for any queries. So the primary objective of the Meta Campus, what we decided, is to implement an immersive VR-based campus, which is supported by an AI narrative guide. So which enables like remote exploration, learning, as well as effective campus orientation. So the system aims to bridge the gap between a physical visit and a digital alternatives. So the related works are like previous research shows like AI-driven VR system, which is used in like training, education, generative AI, which enables like intelligent avatars and environment, virtual campus, but it all still lacks like an either real-time environment or an immersive campus too. So this is the gap which we identified, which we're going to overcome by proposing the Meta Campus. So coming to proposed methodology. So like the previous studies have demonstrated, what I missed is like the VR campus virtual tour and the AI one. So by integrating, we are bringing the Meta Campus. By starting is the data acquisition. So we need to exactly replicate a campus. We're gonna need a floor plan, which we're gonna need like an images and videos. These will be the data acquisition for us. Then for processing, what software we are using is Blender. Blender is an open source 3D software where we're going to replicate our entire campus by 3D modeling it. So for that, the base would be the floor plans and references would be like images and videos. So the reconstructed environment which we done, like the 3D model which we have done in Blender, got to implement or to integrate in VR, which we're going to use in Unity. Unity is like an game engine for which we're going to use for VR development. And like told, we're going to implement an AI too. So for the AI integration, what we're going to do is we need is a narrative guide. So for which we're going to be implemented in Conway. So it enables the real-time conversational interaction. So finally, the deployment system would be in an VR to ensure like a smooth VR performance and stable frame rates. We're going to do is a system optimization for smoother purposes. So the system architecture, like like what we use is like we told is Blender. These are like the rendered images which we got from the Blender. So this is our college. We are coming from Rajakshmi Engineering College. So this is our campus, like the outside, and this is the interior of the classroom, which are modeled in 3D using Blender. Then the like the XR interaction toolkit, which we have used is for the navigation, which is the VR part is implemented in Unity. So finally, the Conway is an API which we called in Unity, which is for the AI-driven avatar interactions, which will give you the real-time responses for the virtual environment. So coming to implementation, so during the implementation, the campus buildings and interiors were modeled and as well as optimized in Blender to reduce the polygon count, as well as because when going to VR, like it is a three-dimensional, so like many people can get dizziness and all. So for that, what we did is optimization, which is and played a major role, but still we need some to look realistic. So both we done in Blender. Then the assets were all assembled. Assets in the sense the campus and models were also assembled in Unity 3 for the VR integration. And this is the Conway platform, which is the AI avatar. We can replicate any person as a 3D character and can bring them as an AI and we can give the knowledge bank a narrative design for them to have the real queries to communicate and interact with them. So the system was tested like in both PC VR, and we're going to deploy in MetaQuest, which is the VR itself, which is a standalone. And the result and analysis, we implemented system successfully achieved accurate and realistic 3D campus recreation comparing with our college model. The AI avatar demonstrated the ability to answer like the contextual location-based queries, or we can like pre-define the queries, or we can also ask from the general queries. And the performance optimization resulted in stable frame rates after the optimization, ensuring both the like the user comfort and immersion. So the system maintained consistent interaction across the VR platforms. So the AI narrative integration of AI narrative, which brought the user engagement and realism, and VR-based interaction allows users to better like the understand the compare facilities to like traditional medias, which is like a videos or like a 360 videos. More than that, the our VR-based interaction improves. The system is suitable for student admission. You can take it like for various purposes. It can be used like student admissions, institutional outreach, or orientation programs. So the coming to conclusion, MetaCampus effectively integrates artificial intelligence and virtual reality to deliver an immersive, interactive campus tour experience. The system successfully bridges the gap between physical and digital campus visits. Additionally, provides like a strong foundation for like a VR-based learning environment and education metaverse. Like I'll come to that point in the future. Like what I was telling, like multi-user thing. Like like in COVID or time during that time, we were all taking online classes and attending in Zoom meeting. So the next upgrade is would be like seeing in VR. So everyone will be getting an 3D avatar like which is on Conway. So everyone will be having their own avatars and will be taking their classes in home, but in a VR headset. So which is and this is a single one which we have done. So the next upgrade would be like the multi-user one, and we can use it for gamified lessons, and we're using advanced AI personalization cloud-based, which allows like the large-scale institution adopts, and metaverse integration is the one which is done by the Meta as an example. And these are the references which have been taken by the other papers. And yeah, that's all. Thank you. Any questions? Hello.
Yes, sir. Sir, do you have any questions, Rathore sir? I take it as a no. Let's move further. Next, we have Yashwant N. He's presenting named entity recognition for healthcare, a comparative survey.
Yeah, sir. Just a minute, I'll just share my screen.
Yes, sir.
Hello.
Yes, sir.
Who is next?
Yes, he's sharing his screen. Yashwant
Yes,
N.
just a minute.
Okay.
Is my screen
Yes, sir.
visible?
You can start.
Just yeah. Like coming to our project, this is a survey which is conducted on name entity recognition for the healthcare sector, and these are our table of contents like abstract, introduction, review, datasets. And coming to our abstract, as we know that in clinical sector, there is a huge amount of data which is being generated on the daily basis, in which most of them are unstructured uh, unstructured data. So extracting entities from these are quite difficult by using the normal approaches, because most of the approaches may have like, they may get confused based on the entity names and other things. So the recent transformer based LLM or LLM based have significantly improved the healthcare performance. And we have taken the papers from 2022 to 2025 and made a comparative study based on the traditional transformer based and LLM based approaches. And we are proposing a multimodal ensemble based approach to uh, so coming to the introduction, like as I said, healthcare data is largely unstructured data, where we have EHR, like electronic health records, clinical notes, reports, and other prescription wise. So manual information extraction becomes way time consuming, and due to which, like, entities such as diseases, drugs, and other symptoms can be extracted using NER approaches. So and also there are recent advancement in BioBot, PubMed, and ClinicalBot, and other BERT related architecture and transformer based approaches. So coming to the review part, we have classified it based on the models and this one's like coming to the traditional versus early transformer based models. The early is transformer were performing better compared to the traditional models, because there was a limitation in the traditional models, like they can't correctly identify the entities, due to which there was some ambiguity between that. And coming to the traditional transformer based and hybrid deep learning approaches, it was covering like combining transformer with CNN by LSTM and other things. These were designed to capture the information and long range dependencies in clinical test. But in by LSTM, as we know, like it also has some limitations, like if we go on uh, if it is a long sequence of data, so the previous ones which are we the model cannot take the oldest data accurately. So by using transformer based, we are just picking up the required uh, data from it, due to which it got an accuracy of 93%, but it was failed to generalize the different clinical data set. Coming to the prompt driven and LLM based approaches, like LLM models such as GPT 3.5 and 4 were applied to the healthcare NER using prompt engineering. But and these were quite good and reached a maximum of 95% accuracy and F1 score. But the drawback for this approaches is that prompt sensitivity and high computational,
Hello.
which is
Hey,
hello,
hello. This
hello,
is
yes, sir,
science literature review. Just show your work.
yes, sir. Uh, Coming to the data set which we have analyzed, like
Where is the proposed architecture? Have you made?
yes, sir, here. Coming to the architecture, like we have planned for the multiple transformer ensemble model, like BioBird, PubMed, and Clinical Bird. These are trained on different data set with the same architecture. as we know, like all the models, like uh, a single model cannot perform best for all type of data sets. So by using multiple data sets, we can generalize and get the correct
What is
output.
tokenization?
Like the data or the, like, for example, if we have a sentence, it is being split into words, like and tokenized, and also we're removing the unwanted text from that, like nouns, pronouns, and other things. Taking the input, the text preprocessing is being done by tokenizing and normalizing the data, and each token is being tagged in bio format, which is begin, intermediate, at out, in which begin and intermediate will be taken as, as true, and considering O, which is out of the context, which is being classified as not a medical text or that entity. So this is being passed into the multiple uh, transformers, where each of them will
On
predict.
which disease, on which disease that you are working?
Sir,
On which disease that you have worked for, like heart disease?
sir, it is basically for diseases, for entity recognition, like what are the diseases and drugs, and which are the medication being used. So based on that, the
Here we have written like diabetes, disease, diabetes,
yeah, yes,
drug.
yes, sir, metformin.
Mm, Okay, fine.
Yeah,
Conclude in 1 minute, please.
yes. So coming to the conclusion part, the transformer based and LLM based approach have worked really well in the recent times, and when we use the domain specific pre-trained models for the entity recognition, the accuracy is more, and there are some challenges with privacy and deployment, and also with the availability of the data, as this is based on the healthcare sector. So our approach is a multimodal ensemble approach for improved robustness by considering different categories of data. So and also using some of the synthetic data to overcome the data availability and other things.
Okay, fine. Next, please.
Thank you, sir.
Thank-
Next, we have
just
Gareth A. Gehrig. He is presenting object-centric process mining with a communication architecture.
Yes, yeah. Just give me a moment to share my screen.
Yeah.
I think you can see my screen.
Yeah, it's visible. You can proceed.
Okay, awesome. Thank you all, and good day, and welcome to my presentation on object-centric mining with a communication architecture. I'll be your presenter for this paper, along with my colleagues of Professor Kyriakos and Professor Vermark. To jump into our overview of our presentation, we'll look at the background of smart manufacturing, the shortfalls that exist in the current implementations and why this matters, the opportunity we have identified within smart manufacturing and the synergies between object-centric processing, our approach to this issue at hand, and the results obtained early on in our ongoing study, and as well as why this matters and any key takeaways from the study. Smart manufacturing promises to introduce intelligence and flexibility into the manufacturing process by introducing traits and characteristics into the machines themselves. However, in practice, this results in large data groupings that are processed in central locations and with extensive software layers. This limits the distribution and agility of the smart manufacturing units themselves. Existing architectures through hardware and software implementations help to overcome these challenges, but there are still large gaps that exist when closing the threads between communication protocols and smart manufacturing units. This results in fragmented information, increasing latency, and a loss of machine autonomy of intelligence for smart manufacturing units. Object-centric processes are supposed to further improve manufacturing processes by grouping, classifying, and revealing inefficiencies in processes done in manufacturing. This is done by describing processes around real objects, creating clear data rudiments, and removing the traditional post-production analysis by bringing it within real time of the production processes themselves. However, with a lackluster implementation of smart manufacturing implementations, this object-centric approach only feeds the problem of large data groups and a further reliance on inefficient software overheads. This is overcome with the implementation of our communication architecture that allows for a decentralized and real-time communication between smart manufacturing units. A custom communication protocol drives the interaction at machine level, allowing for contextually aware machines on a network to be realized. This allows machines to self-identify other machines it is connected to and its sensors in the environment. Since this information allows for machines to self-identify other machines in its environment, and it works at the communication protocol level, this information is directly accessible to each individual machine throughout the network and can shared in near instantaneous metrics. Next, we are able to create both a distributed and specific network object-centric process flow from the central server that is distributed to all central machines, still allowing us to make use of the central server for further data analytics post-production, but still including the actual OCP flows within the individual machines themselves. The machines are able to discuss amongst themselves the grouping of repetitive tasks of where they are best situated amongst the machines without the oversight of the central server, allowing for OCP flows to be customized with the intelligence of the machines rather than the network. For some of the theoretical results, this allows machines to become next, we are able to create both the For some of the theoretical results, this allowed machines to become reactive and remove traditional post-processing of OPC flows for its improvements, where machines are also able to coordinate and recognize tasks throughout the network by communicating amongst themselves. For some of the quality level results, for some of the qualitative results, this allowed SMUs to create automated decisions based on the machine and production information they collected, while allowing autonomy for production and network distributed tasks. For some of the simulated results of our system, we were able to see a production efficiency improvement of 13% when using a random feed-in model, with the largest contributor of this information being in the reduced idle time of machines and allowing machines to prepare for the next product in production through the communication of any preluding machines of the information while using the communication architecture and protocol to distribute this information. This implementation shifts the intelligence of data analytics, contextual awareness, and appropriate information to the machine level themselves, instead of the machines becoming a conduit of information from central servers. This helps reduce software overheads by distributing network and production tasks amongst the machines, while early evaluations allow for scalability through the use of the communication architecture, communication protocol, and object-centric processes to be continuously distributed amongst the ever-growing amount of machines within the network. Thank you. And if you have any questions, I'm happy to answer.
Hello, Gareth. Nice
Yes.
presentation.
Thank you.
So what are the applications of your research?
For now, we evaluated it onto a water bottling plant where each of the machines were distributed for a specific task within the water bottling plant, a bottle filler, bottle capper, and a packager towards different machines. While we originally developed the communication protocol and architecture to be almost generalistic to be applied into any machine, so automotive or space or any other types of manufacturing, we tried to focus a little bit onto that specific product to iron out a lot of those details. So for that application, within the communication protocol itself, we allow for a distributed list of any machine identifiers so that all machines within the current production space are named and then can be self-identified for all the other machines. So we hope to try and distribute this out for a bit more of a smart manufacturing realization in for future manufacturing and smart cities. But for now, it would just be a improvement into production efficiencies with pilot studies and commercial products.
Okay, nice. Fine. Good. Okay, fine. Okay, next, next please.
Next, we have Pracheta Kadam. She is presenting smart skincare recommendation system using artificial intelligence and machine learning.
Am I audible, sir?
Yeah, ma'am, you are audible. You can start your presentation.
Good afternoon, everyone. My name is Pracheta Kadam, and I am from Modern Education Society's College of Engineering, Pune. My topic for today is Smart Skincare Recommendation System using Artificial Intelligence and Machine Learning. My paper ID is 794. The skincare industry is rapidly evolving with customers seeking for personalized product recommendation that cater to their unique skin type and concern. A well-designed recommendation system can significantly enhance user engagement by offering tailored solutions based on individual needs and preferences. Skincare has become an important part of daily life, and not only girls, but increasingly for boys as well. Today, people are more conscious about their appearance, skin health, and self care. However, with thousands of products available online and offline, user often feels confused while choosing the right product. Many people rely on Instagram influencers, but most influencers are paid to promote those products, and their recommendation may not always be genuine or suitable for everyone. Also, not everyone can afford regular dermatologist consultations, which makes personalized guidance inaccessible to many users. To solve this problem, our project introduces a web-based AI and ML powered skincare recommendation system that provides affordable, personalized, and trustworthy product suggestions. The main problem users face is overwhelming number of skincare products, paid promotion and misleading influencer marketing, lack of expert guidance, high cost of dermatologist consultations, and trial and error leading to skin damage. With countless skincare products available in the market, users often struggle to identify which products are suitable for their unique skin type. The lack of personalization leads to confusion, ineffective product use, and even adverse skin reaction. There is a need for an intelligent system that can analyze individual skin profile and preferences to provide accurate personalized skincare product recommendation, saving time, improving skin health, and enhancing user satisfaction. Most current solutions often are generic solution. That is, they follow a one size fits to all approach, which does not work because skin types and conditions are very unique and vary greatly. There is a need of intelligent system that can analyze intrinsic factors like skin type and sensitivity, as well as extrinsic factors like climate, pollution, and lifestyle. Our system solves this by providing a data-driven, unbiased, and personalized recommendations. Our motivation comes from real-life observation. Skincare demand is rising among both girls and boys. Among 60% female use skincare products daily, and even male use almost 35%, and elderly, which are 5%. People demand the people depend heavily on social media influencers who may not be trustworthy. Also, dermatologist visits are very expensive and not accessible to everyone. Users also want scientific explanation and not marketing claims. Artificial intelligence enables dynamic personalization where recommendations adapt based on user skin need and environment. This motivated us to design a smart and alternative to traditional skincare advice. The objectives are to develop a user-friendly platform, to analyze skin type concerns, preferences, and allergies, to apply AI and machine learning algorithms for accurate recommendation, to create an ingredient-based knowledge base, to educate user about why a product is recommended, to reduce dependency on influencer marketing, also to make skincare guidance accessible without expensive dermatologist visits, and
Hello.
to ensure scalability and future development.
Hello. Yes, ma'am. Show us your proposed architecture. So we can
Yes, sir.
yeah.
So the first stage will be user interface, that is the input layer. First, the user interacts with a web-based interface. Here, the user provides inputs such as skin type, like oily, dry combination, sensitive, or their skin concerns, like acne, pigmentation, dryness, or aging, and product preferences and allergies. And they can also enter location or environmental detail. This step ensures personalization data collection instead of generic assumption.
Can't see your.
Second is a data.
We can't see your PPT. Hello.
Yes, sir. So is it visible now?
Yes, it is visible, but we can't see your proposed architecture. Where is it? Go down.
Uh,
Go down. Hmm. You don't have.
no, sir.
Okay, so what is the novelty in your research?
Uh,
Just identifying the things like whether the patient having the skin disease or not.
so not exactly skin disease. We are going to take input about their skin concerns, and we are going to suggest them products which they can use. And
How? So which features
for
that you have,
that,
which features
so we
that you have considered for this kind of disease?
So first we are going to use like the classification model, where like the entered user skin category, such as first suppose there is oily, dry, acne prone, the user has to enter. Then we'll classify this categories. Then we'll apply content-based filtering. That is recommend product based on the user skin profile, which matches skin type, concern, and ingredient compatibility. Then
If
for
if
then
someone
third,
wait,
okay,
if someone passing the wrong values, then what happens?
okay. So
Suppose,
we are also going to take image-based input data. And for that we are going to use OpenCV.
no, what I'm asking to you, like
Okay,
you just told us like some of having the oily skin, okay, but
okay,
I am having the oily skin, but I am putting my wrong data into your research. Fine.
okay.
So what will be the output? How do you know
Uh,
whether my skin is oily or not?
so honestly, then that will recommend a wrong product, which will not be beneficial for the user only. So I don't think the user will enter any wrong data.
It's your perception, but it is not like that.
So then wrong product will be recommended.
But how you identify whether the patient having the skin disease or not? Because ultimately your title is like skin care. Fine.
Yes.
So first of all, you have to identify whether the patient having the skin disease or not for the classification. So how you identify?
So we'll use algorithm like logistic regression, random forest, or decision tree, where the input will be suppose skin type and concern, then the output will be acne prone skin. Then we'll do content based filtering.
First of all, you need to clear about the things like if you are using machine learning algorithm, then it should be worked on the binary data set. Okay. If you are
Okay.
using some images, then you should go for the CNN kind of algorithm.
Yes.
Okay. Random forest will not work for the image classification,
Image-based.
image
Yeah.
data set.
Yes.
Okay. We'll conclude in 1 minute, please.
Okay. So these are the already uh, uh, these are the references which we followed, and we found out some limitation. That is, it was only limited to facial skincare, and they were not providing holistic routines. We will provide them proper routine about which toner to use, which serum to use, which moisturizer to use, which will suit them properly. Then the second one mainly focused on the ingredient data. It was ignoring the lifestyle and the environmental factors. Like suppose a person living near coastal area might need high use of sunscreen, high use of SPF, and it was the third one was only restricted to acne cases, and fourth one had high hardware cost,
Okay,
and
fine.
the last.
Okay, fine. Good enough. Okay, next, please.
Thank you, ma'am. Next we have, just let me share my screen. Yeah. So next we have Vishnu Akyutham Menon. He is presenting rule-based and NLP-driven sentiment classification of geopolitical narratives, a case study of India-Pakistan coverage in global news.
Thank you. So my study is about basically about India-Pakistan coverage and in the global aspect. Basically, it's about analyzing the news that we have scrapped. So I'm not going in depth to the what do you call the details between what is between India and Pakistan, but the to give to start with our objectives. Uh, so the study seeks to contribute to into interdisciplinary fields of media studies, international relations, and computational linguistics. So by applying hybrid methodology of rule-based NLP sentiment classification, and so what we did is we have scrapped data set comprising of 7,596 which has 7,596 multilingual news. So which has uh, so the data included attributes like country, language, and publication date. So as part of pre-processing, all the headlines were translated into English using tools like Google Translation, followed by normalization techniques such as converting text to lowercase and removing functions. Then sentiment classification was carried out, followed by then headlines mentioning both were tagged as unclear sentiment while others remain neutral. A sentiment distribution was then performed by creating pivot tables grouped by country and month, and results were visualized through bars, plots to identify patterns across regions and time. So we have three research questions. For one research, first RQ was to can a rule-based sentiment classification model effectively detect biases toward India or Pakistan global news headlines? So this is a table. So you can see how it has been classified as neutral, pro-India, pro-Pakistan, pro-unclear, negative, and unclear positive. So the findings uh, shows that the rule-based sentiment classification model is effective as a baseline tool for detecting overt and polarity aligned biases toward India or Pakistan in global news. So most headlines are classified as neutral, while explicit pro-India or pro-Pakistan sentiment is rare. A significant number of headlines fall into unclear positive and unclear negative categories, especially when both countries are mentioned, indicating the model's ability to flag ambiguous sentiment without forced labeling. However, due to its lexicon-based nature, the model has limitations in capturing implicit bias, sarcasm, or contextual nuances, suggesting the need for more advanced method for deeper analysis. We had the second research questions were what are the patterns of sentiment pro India, pro Pak, neutral emerge across different countries or languages. So across countries and languages, neutral sentiment dominates news coverage of India Pakistan news. Uh, Indian media shows a high level of neutral reporting with sizable share of unclear sentiment due to frequent joint mentions of both countries, but very few explicitly pro India or pro Pakistan headlines. Similarly, US and UK media largely remain neutral, with some emotion laden coverage reflected in unclear positive and unclear negative categories rather than overt bias. Explicit partisan sentiments is rare across all regions, suggesting either deliberate media neutrality or the limited ability of rule-based methods to capture subtle framing and implicit bias. Our research question was third RQ was to how consistent is the sentiment distribution over time from April to May. So country wise, you can see it here. Now the next is you can see the monthly trend of sentiment categories. So the sentiment distribution is not fully consistent over time between April and May, although uh, the neutral sentiment remains dominant in both the months. Its relative proportion decreases in May as volume of news increases. At the same time, unclear positive and unclear negative sentiments rise noticeably, indicating a shift toward more nuisance and emotionally mixed reporting as conflict evolved. So, pro India, pro Pak sentiments remain negligible across both months. The results suggest a move from largely neutral coverage in April to a more complex and uncertain sentiment framing in May. So, to conclude the study reveals that the global news coverage of 2005 India Pakistan conflict is predominantly neutral with uh, minimal explicit pro India or pro Pakistan sentiment. Most headlines were classified as neutral, especially from countries like India, the US, and UK, suggesting a preference for balanced or objective reporting. So, instances of emotionally charged language captured under unclear positive or unclear negative were common in headlines that mention both countries, particularly in May, when coverage increased and sentiment patterns became more complex. The rule-based text block classifier supported by keyword-driven sentiment tagging proved effective in flagging these notion headlines, through it showed limitations in capturing implicit or sarcastic tones. Thank you. So the study was an experiment, or we were learning sentiment analysis. So how the sentiment analysis could work in the headlines, because I teach in the Department of Mass Communication Media Studies. So this was an experiment for us, to learn these methods. Uh, so that's what aftermath of this, this thing. Thank you.
Okay, can I have your title, please?
Yes, can you repeat?
Can I have your title, please?
Our rule-based and NLP-driven sentiment classification of geopolitical narratives, a case study of India, Pakistan coverage in global news.
Okay, but I haven't seen like any NLP or rule-based classification in your presentation.
Okay.
It's just
I
a
think
kind of
it was
it's a kind of like theory only. But
okay.
what you have
Okay.
gone through the research, like have you applied any algorithm based on you get the result likewise?
Hmm.
I'm not able to find any programming through which you can have the output.
Okay. Okay.
Okay, so you have to put some kind of like programming methods, machine learning methods, as you have written over there, NLP.
Okay.
Okay, fine.
Thank you.
Okay, I am done, sir.
Thank you, sir. So before moving further, do we have Saurabh Jain or any co-authors from his team? Okay, I take it as a no. So this was the last presentation for this session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on the behalf of her team, thank you for support. Thank you for the support during the 10th version and all the previous 9 versions for the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates within 2 working days. The publication will be live within 7 to 8 months, so kindly cooperate with the team of ICTCS 2025. Let me share my screen. Thank our session chair, Dr. Dushyant Singh B. Rathod, for chairing the session. A token of appreciation to the chair of the session from team ICTCS 2025 and Global Knowledge Research Foundation and partners. Sir, do you have any closing remarks for the participants?
Yes, sir. Thank you so much. I am very thankful to the organization secretary and all the peoples, those who invite me as a session chair. I've been with the ICTCS, ICTS since 5 years, and I've seen that so many research scholars, so many people, they have presented the paper in a different manner, having the different number of titles in the era of machine learning, blockchain, and cyber also. So keep going on and participate in the conference as well. So that's it. Thank you so much for inviting me once again.
Thank you, sir.
Thank you, sir.
I
Thank you.
kindly request everyone to switch on their cameras for a quick snapshot of the session. Thank you, everyone. Have a safe